Good morning, everyone. My name is Melvin Lebihan. I am scientific consultant at Scientific Volume Imaging, and today I will present an overview of the Huygens Stitcher, highlight the latest update of the stitching module, and at the end of the webinar, provide a quick demonstration of how to stitch an image with Huygens. Stitching allows for the imaging of large biological samples while maintaining the high resolution needed by capturing more tiles at a higher magnification and a smaller field of view. The stitching process is carried out by Huygens Stitcher Wizard, an implement tool with for goal to create a one artifact free image. Here is a selection of the main feature of the Huygens Stitcher. Huygens Stitcher has no limit on the number of tiles, channel, or image size, and it can be performed both 2D and 3D stitching. It provides optimal registration or alignment of the tile in X, Y, and Z, and you have the possibility to tiles with 0% overlaps between the tiles. It includes different options as vignetting correction tool, and you can also couple the deconvolution step of the tiles before stitching. The deconvolution, optimization of the alignment, and vignetting correction benefit from the implemented GPU acceleration and the optimal use of CPU. The latest additions are that you can now choose the data type used for stitching and save it in 16-bit integer data type, which allow you to save memory. In case of also that your images are too large for the RAM of your computer, the memory map file is now available for temporary and result image. A low memory option for optimization in X, Y, and Z can drastically reduce the memory requirement for 3D optimization of tile with large overlap. You have also now the possibility to create a stitching template, which can be used in the workflow processor in Huygens for a fully automated process. And we have implemented recently a new vignetting estimation mode, allows for vignetting correction even for image with few tiles. At the start of the stitching process, you have now full access over the data type you want to use for the stitching process in Huygens. Smaller data type will speed up the process, while larger data type can reduce stitching artifacts. One of the most important steps in the stitcher will be the acquisition layout. When opening an image with the Huygens Stitcher, the acquisition layout and the tile information can be automatically read from various file formats, such as CZDI, LIF, and D2, for example. If you are using a tile series from TIFF format, for example, which doesn't contain metadata information, the layout can be customized within the stitcher with different custom patterns and can be saved as an XML file. The next step of the wizard is the alignment optimization of the tile, which is done for each tile with respect to its neighborhood using a cross-correlation approach, as you can see here in the small scheme. This alignment process is also supported for 3D tiles in Huygens. You will at the end get an optimal alignment of all your tiles before the stitching process. This step can be skipped, but it is necessary to have this step if you want to correct for different artifacts, such as image doubling, stripping, or misalignment, as you can see here, for example, in this example. For all this process, the number of tile and image size are unlimited in Huygens. The hardware will be the real limiting factor. Here, you can see an example of an image taken from a Zeiss Lightsheet 7 of the hippocampus of a clear adult mouse brain, which were over 250 gigabytes. Following the tile alignment, Huygens offers the user the possibility to correct for vignetting and enhance the contrast and resolution of the tile with deconvolution. Within the Huygens Stitcher, this vignetting can be addressed with two different methods. The manual approach is to load a dark field and fly field image within the Stitcher wizard. You can find a protocol on how to acquire dark field and fly field image in our website if you are interested by it. The automatic approach is to select a vignetting model. The vignetting estimation mode, based on tile region, will automatically estimate and correct the vignetting artifact present in the tiles. You can see here a stitch image that clearly shows vignetting artifact at the left of the screen, which were properly correcting using the vignetting estimation mode based on tile region at the right. For this estimation mode, based on tile information, it often requires a large amount of tile to be optimal. We have recently developed and implemented in Huygens a new vignetting estimation mode based on radial variation that also allows vignetting correction on just a few tiles. As you can see in this example of a spheroid image, which contains only 4 tiles, and where we corrected for vignetting correction using the new estimation mode based on radial variation on the image at the right. As mentioned, the Huygens Stitcher also gives the possibility to deconvolve the tiles before they are stitched. This can be done by loading a deconvolution template file from Huygens during one of the steps of the Stitcher wizard. You can choose whether or not to apply this step during the stitching process. The final step of the process is the stitching of the tiles. The Stitcher wizard in Huygens has been optimized to be user-friendly as possible, and at each stage of the process that I presented you previously, a wizard help window will provide information about the process and guide you through each step. Huygens ensure a minimal use of the computer resources for alignment optimization, vignetting correction, and deconvolution process. We benefit also from the GPU acceleration. As mentioned, we have also a new option, low memory option, that enable also increase of speed of the stitching process and especially of the alignment of the tiles by reducing the memory required for tiles with a large overlap. The entire setting for alignment optimization and vignetting correction can now be saved in Huygens template format, which can then be used in the workflow processor in Huygens for a completely automated stitching process on other similar files. For your information, for specific light sheet dataset that contain different view angle of the sample, a fusion module is available in Huygens, and it allows both stitching of the tile and the fusion of the different angle of the sample, as you can see here in this example. I would like to thank you all for your attention. I will now give a demonstration of the Stitcher wizard in Huygens. If you have any questions following this webinar, you can send them by email at support@svi.nl. Also, if you haven't done so yet, feel free to register for our upcoming webinar on matrix TED or workflow processor in Huygens. If you are interested by it, we will also have a free online workshop on the May 15th. I will now start the demonstration of the Huygens Stitcher wizard in Huygens. The Huygens Stitcher wizard can be found under the tab Deconvolution, Tile Stitching, and Decon Wizard. When opened, the first step will be to select the file that you want to stitch. For this demonstration, I will use a spheroid image taken with a Zeiss Lightsheet 7 microscope. The format of the file are .czi. And for this demonstration, I will select the 4 different tiles of this image and stitch them. After uploading the image that you want to stitch, Huygens will propose you to load a template that you can now save at the end of the stitching process and reuse for other stitching, or use it in the workflow processor in Huygens. For this demonstration, I will show you step by step how to stitch an image. On this next step, you have now the possibility to choose a data type used for the stitching. The auto choice will select the data type will use the less memory possible and that can have all the information on the image. And we will use this one for this demonstration. The acquisition pattern setting is the next step. All this information are already present here because they were read by Huygens in the metadata present in the .czi format. In case that you have file which does not contain information regarding the pattern selection and the acquisition pattern of the tile, you have the possibility to actually make them your own by changing the different information as acquisition pattern or overlap between the tiles. To confirm that the tiles are properly registered, you have the possibility to show the tiles or a maximum intensity projection here. The Windows warning open is to mention to you that this might take a bit of time in case that you have a large image and high number of tiles. In our case, we see that the registration of the tile were properly read, and that we can now start the stitching process. You have the possibility also to select only specific tiles that you want to stitch together in this step. The next step is to select for vignetting correction. You have the possibility to pass this step or to use an automatic model or the manual one that I presented if you have flight field and dark field image. In our case, we will use the automatic correction vignetting tools. The vignetting correction can be done for the channel of your choice. You have then to select the model of the vignetting. By default, the circular one will be selected. And then to choose the estimation mode that you want for the vignetting correction. The default mode based on tile information or region will not be used in this case because it contains too few tiles. So I will use a new estimation vignetting model based on radial variation. This estimation mode, as mentioned during the webinar, allows to correct for vignetting correction even with few tiles. However, you might need to adjust the vignetting adjustment with a slicer, and the adjustment will be dependent of the type of image that you have, number of tiles, and information containing in the image. For this image, we have already know that by setting up the slicer at 1, we can get the optimal vignetting correction result. The next step will be the optimization of the tile alignment. As for the vignetting correction, you can also choose to perform this optimization only for the channel of your choice. You can optimally align the tiles in X and Y and Z. We have also the low memory option, allowing to speed the process in case that you have large overlap between the tiles. And you have also the option to align only in X and Y, not in Z, or to pass this step. The prefilter intensity outlier can be selected in case that you have stitch image taken from a camera-based microscope and can help to reduce the salt and pepper noise if you have, for example, hot pixel in your image. This step is only for the alignment process and will not change anything in the intensity of your image on the stitch image at the end. For this step, you can have GPU acceleration, and to give you an estimation of the time that it takes for this process of vignetting correction estimation and optimization of the tile alignment, I will speed up the video by 10. We arrive now to the last step of the stitching process, which is the stitch of the tile. Before the step, in this window, you have the possibility to load microscopic parameter of the image if your image does not contain metadata that can be read by Huygens, and to apply a deconvolution template if you wish to do deconvolution of the tile before the stitching process. It's also at this step that you can save the stitching template, which will contain information about the tile alignment optimization, vignetting correction, and acquisition pattern. And you can then start the stitch of the tile. As you may have seen, at the top right of my window, I previously stitched this image without applying any vignetting correction. And we now can compare the image result obtained. At the end of the stitching process, when the stitching is done, you can save your image in different data with different data type, or you can restart the vignetting if you want. By pressing down, the image will be open in the Huygens main windows, and we can then compare the result obtained with the normal stitching in Huygens with the one where we applied vignetting correction. And as you can see here already presented in the webinar, you can obtain a good vignetting correction with a new estimation model, even if your stitch image contains only 4 tiles. With this example, I would like to thank you all to have watched this webinar, and I want to also again mention that if you have any question, you can contact us by email at support@svi.nl. Thank you very much.